So let's take a look at an example that's going to use the law of cosines. What I'd like to do is I'd like to solve a triangle if side A is 53 inches, side B is 86 inches, side C is 62 inches, and then I'm going to make sure I round my angles to the nearest tenth of a degree. Notice this is the side situation, and again, I don't necessarily care so much that it's side. I'll never ask you which situation it is, but side is one of the law of cosines situations. So if I draw a triangle, it might not be helpful. I usually do, but on this one, I guess I chose not to. Now, I know all three sides, so what I need to find are all three angles. So I decided first to find angle C. Mostly I did that because that's the way my original formula was written, and I thought, well, that's the one we'd be most comfortable with. So I'm going to use c squared equals a squared plus b squared minus 2ab cosine of angle C. And I just plug in what I know. 62 squared equals 53 squared plus 86 squared minus 2 times 53 times 86 cosine of C. And I solve for C. Be really careful. I've seen some goofy algebra that students do. So make sure that you're really careful with your algebra. So if I do this, and actually the way I chose to solve for it, just to clarify, I actually moved the 62 squared over to the right hand side. So I had 53 squared plus 86 squared minus 62 squared. And then I took that negative 2 times 53 times 86 times cosine of angle C, and I moved that to the left hand side. So what I did was I made the cosine C term be positive by moving it to the other side. So, and then once I did that, I had a little division to do. So I ended up with solving for cosine C, giving me 53 squared plus 86 squared minus 62 squared all over 2 times 53 times 86. And when I did that math out, and you'll want to make sure when you do this math out that you store it in your calculator to keep this. Don't round a very few decimal places. It will really affect the accuracy of your answer. So I ended up with 0.697784116. And so now I know that's what the cosine of the angle is. Now, in order to get the actual angle, we go back to what we learned in the previous section, and we take the inverse cosine of each side. And when I do that, what I learn is that angle C is the inverse cosine of 0.697784116, and that gives me approximately 45.8 degrees. And again, I rounded to one decimal place because that's what the instructions said. Now I'm going to do the same thing to find a second angle. I chose to do it to find angle B. So I used b squared equals a squared plus c squared minus 2ac cosine of b. You'll notice, and you might be wondering about this, I put the little multiplication symbol in here. I thought it was going to look kind of goofy, looking like ac cos b, that it might be hard for people to see. So now if I substitute in, though, I end up with 86 squared is 53 squared plus 62 squared minus 2 times 53 times 62 cosine of b. Doing the same algebra I did before, I solve for cosine b, and I actually learned that cosine b is negative this time, negative 0.113055386. And again, I take the inverse cosine, and the inverse cosine is going to give me a 96.5 degree angle, which you'll notice I would expect because cosine's negative, and remember, cosine's negative in quadrant 2 and 3. The only way I'm going to get a triangle is if my angles are all less than 180 degrees, because remember they all have to add up to 180 degrees. So so that 96.5, the second quadrant answer, is exactly what I'd be looking for. And then once we know the two angles, we could use the law of cosines a third time, or we could say, okay, I know that these two, let me just subtract their sum from 180. I usually try both, and I do it as a check and a balance just to make sure. On this one, I just did the subtraction, however.